Okay, so we're gonna go to the second part of estimating radicals. We're gonna estimate radicals to the closest decimal designation. Just having a minute here with the image mate, so we're gonna reopen that. Okay, here we go, back up. Okay, so estimating radicals to the closest decimal designation. And what that means is that we can be asked to estimate to different things. We might be asked to estimate the radical to the closest tenth, or the closest hundredth, or the closest thousandth. So the decimal destination is what has to be provided to you in the problem. Where do they want you to estimate it closest to? So okay, the step or the rule. Okay, step number 1 is going to be the same thing that we wrote previously. So use perfect number chart or your calculator to determine which two perfect numbers the radicand value lies between, and their root or integer value. So step 1 here is going to the same step 1 that we used when we were estimating to the closest integer. Step 2, similar, a little different. We're going to calculate the range. And we're still going to have the largest perfect number, and we're going to subtract the smallest perfect number. Now, we're not going to divide by 2 like we did when we're going to the closest integer, because here we have to estimate it to a decimal designation. So we're not worried about, is it at least half or greater than half, less than half? We want to be more precise. Step 3. Calculate how far apart each radicand value is on the rational number line. And this is based on the decimal designation. So remember, we're trying to, essentially overlay 2 different number lines and find out how one relates to the other. So every number is equidistant apart, and we're overlaying that on the rational number. We know how many radicals should fit in between the 2 integer numbers, and that's what we're going to use to help us figure that out. So we're going to take the decimal designation we're going to divide it by the range, which we calculated in step 2. And we're going to get an answer. And then multiply that answer by the decimal designation. So if it's hundreds, tens, thousands, that is represented different for the DD, right? Like tens is 0.1 is tenths, 0.01 is hundredths, 0.001 is thousandths, etc. Okay. Step 4. Calculate the range between the original radicand value, or the ORV, and the SP smallest perfect number. And then multiply that by the value determined in step 3. So remember, there's a whole bunch of radicals in between these two integers. And now we're basically finding out, like, is this the third radical in a radicand value in? Is it the fourth, fifth, etc.? Did that in a different color, so this in a different color. So original radicand value minus smallest perfect number multiplied by the value we calculated in step 3. And I know it seems like a lot, but none of these values are very hard to come up with. So step 5, add the value from step 4 to the original radicand value. So step 4 plus original the radicand value. And that's going to equal, you got it, our answer. So let's do radical 57 again. And we're going to do it to the closest hundredth. Okay, so radical 57, and we're going to the closest hundredth. So we already know it's between the perfect numbers of 49 and 64. So small perfect number, large perfect number, and radical 49 equals 7, and radical 64 equals 8. Calculate the range. We already know that it's 15. See, now this is where we stray. So we want to do hundredths. Okay, so when you're dealing with hundreds, that means that if you looked between two integer numbers, right, we're looking between 7 and 8, there'd be like 100 notches between here and here, right? That's what we're figuring. Think of money. There's 100 pennies in a dollar. We're taking those 100 pennies and we're dividing it into 15 different groups. So 100 divided by 15. And that's going to give us 6.67. We're now going to multiply by our decimal designation, which is 0.01. And by the way, this is an approximation, right? Because it was 6.66666, right? It was one of those repeating decimals. We're going with 6.67. And when we multiply that, our value is approximately 0.067. Now, yes, this is the hundreds place, and I'm currently out to the thousands. The reason is because this is all an estimate, right? So I want to keep that thousands place around because this wound up being a never ending decimal. And I want to keep that around until the end where I'm going to cut it down to the hundreds place, just to make sure that I'm not dropping off too much of the estimate because I'm trying to get to the closest hundredth place overall. So then I'm going to calculate the range between the original radicand value, which is 57, and I'm going to subtract out my smallest, which is going to give me 8. So I take 8 because what I'm saying is there are 15 radicand values between radical 49 and radical 64, right? Because there's radical 50, radical 51, radical 52, radical 53, etc. So there's 15 of them from 49 to 64. I'm looking to find out what the value is of the 8th number in radical 57. So radical 50, 1, 2, 3, 4, 5, 6, 7. Radical 57 is the 8th number in. So I'm going to take 8, I'm going to multiply it by the distance on the rational number line in between each one of those radicals. That's what I calculated up above. When I do that, I get 0.536 or approximately 0.54. Now I've rounded it to the hundredths place to make sure nothing drops off. If I just kept it as 0.06, okay, this would have been 0.48. Big difference between 48 pennies and 53 pennies, right? If you're going to the candy store. At least way back in my age when I was, I'm way older than you guys, obviously. So smallest number. And I'm sorry, not messed up a little bit here. Step 4 plus the smallest perfect number. Sorry about that, guys. It's late. So 7, smallest perfect number, plus the value I got here. So as a decimal, radical 57 is approximately worth 7.54. And if I put that into my calculator, we already did. We can see we came up with 7.5498. So 7.54, 7.54. This would actually round to 7.55, but pretty darn close doing it by hand. So 7.54 is our final answer. And that is how you estimate decimals to the hundredths place.